hate these problems.
Matt, you should see the problems that we have to do every single day in class.
It can't be that hard.
Okay, Matt. I'll show you one of the problems that we have to do on an everyday basis. Look. The problem I was given was page 256, number 23. The question states, analyze and sketch a graph of the function. Label any intercepts, relative extrema, points of inflection, and asymptotes. Step 1. The first step I completed was I simply rewrote the equation. Y equals x cubed minus 3x squared plus 3. I noticed that the function is a polynomial function, and the domain is all real numbers. In an equation like this one, it's not easy to find the zeros since it's a cubic polynomial that is also not factorable. Without a graphing utility, we can't exactly see yet where the zeros lie, but we can see where the possible locations are. When y is equal to -1, x is equal to -1. When y is equal to 0, x is equal to 3. When y is equal to 1, x is equal to 1. And when y is equal to 3, x is equal to 3. By doing this, we know that there must be a 0 in those intervals, which are -1, 0, 1, 2, and 2, 3. Step 2 is to find the y-intercept. I did this by plugging in 0 for the function. This would give me y is equal to 0 cubed minus 3 times 0 squared plus 3. By performing this calculation, y would equal 3, giving me the y-intercept. Step 3. Next, to find the x-intercept, I would set y to 0 and solve for x. Since this function is a polynomial, there will be no asymptotes present. I found the x-intercepts by taking the derivative of the previous function. This would give me y prime equals 3x squared minus 6x. I would then plug in 0 for y prime. This would give me 0 is equal to 3x squared minus 6x. I would then factor out to find the zeros. I would have 0 is equal to 3x times x minus 2. I would then find the zeros of that function. I would have 3x is equal to 0. By dividing both sides, I would find a value of x equals 0. Next, I would do the same for the x minus 2 equals 0. I would add 2 to both sides, and that would give me a value of x equals 2. Next, I find the relative maximum and minimum. I do this by taking the derivative of that previous function, which would give me y double prime equals 6x minus 6. I would then plug in the two previous values for x for y here. So I would have y double prime of 0 is equal to -6, which is less than 0. This would give me a relative maximum at x equals 0 for y. I would then plug in 2, so I would have y double prime of 2 is equal to 6, which is greater than 0. This would give me a relative minimum at x equals 2 for y. When x equals 0, y equals 3, and this would give me an interval of 0, 3. When x equals 2, y equals -1, and this would give me an interval of 2, -1. Step 5. In this step, I will be finding the relative extrema. I will set y double prime to 0. This will give me a value of 6x minus 6 is equal to 0. I add 6 to both sides and then divide by 6. And this will give me a value of x equals 1. Y double prime is greater than 0 when x is greater than 1. Y double prime is less than 0 when x is less than 1. This means that I have a point of inflection at x equals 1. The final step is to graph the function. Based upon all of the previous above calculations, this is the graph presented. Now compare that to the problems that you have to do, Matt.
That's a lot harder, Anthony.
I know. So enjoy doing that math because it only gets harder when you hit high school.